Hi everyone. We are looking at a differential equation here given to us as the y dx plus iey equals h of x, where a is a constant. That's why this type of equation is called constant coefficient linear equation. Constant coefficient linear equation. We have classified differential equations. When you see this one, you can't be able to tell that this is a first order differential equation. Why? Because the exponent of the differential here is raised to the power of 1, so it's a first order. And it's a linear equation because you only have your unknown cell, which is y, and y here. It's a non-homogeneous because the right hand side of the equation is not equal to 0. It's equal to something, a function of x. So it is a non-homogeneous constant coefficient first order differential equation. So why do we need this? Because when you want to model real life situations, in most cases you will come up with this type of differential equation, which means we should find means by which we can be able to solve this type of differential equations. Remember, when we are talking about the applications of differential equations, we talked about the population growth or the population dynamics of species in a particular environment. We did mention that the rate of change of population is directly proportional to the population itself. And if you interpret that statement in a mathematical form, this is what you get. The PDT equals Kp, where K here is a constant, it's a number. When you then solve this equation, which we did Isaac Newton's law of cooling, derive the formula and solve it, you will come up with an equation like this. This is the graph of a population growth. All populations, they follow this pattern. This is an exponential growth. Any population, under natural circumstances, they follow this pattern. So if the population starts at P0, say starts with 2,000 people in an island, they come together, give birth, children, and then the population will start to increase. At time T0, with the initial conditions, this is what you get as the answer. So we now know that when the differential equation looks somehow like this, you get the answer like this. We now try to compare this to this one. There are so many ways of solving differential equations. We find the convenient ones, the simple ways of solving them. So let's start from here. This is a non-homogeneous first order linear differential equation. Let's apply some techniques that will enable us to solve this equation. If we multiply this equation, both the left and right hand side of this equation, by e raised to the ax exponents, we multiply throughout by e raised to the ax dy dx plus e raised to the ax ay equals e raised to the ax h of x. I will take this off. We'll need it at this time. Now, we have taken e raised to the power of ax. This a is a constant. It's called Euler's constant. Euler constant. It's 2.78 and some other numbers. So let's see what we can get at. This is a technique we're applying here to be able to derive the answer of this differential equation. We have taken e raised to the power of ax and multiplied it throughout the equation. If we have e raised to the ax dy dx, this is equation 1. Let's stop there first. We are now looking at this differential equation. This is the same as d dx e raised to the ax y. Oh. Right? We are multiplying e raised to the power of ax throughout this equation. We are looking for a mathematical technique that will allow us to solve this problem, this differential equation here, this non-homogeneous first order differential equation, which we also call a constant coefficient differential equation. The constant because of this is the independent variable. This is what we are looking at, the y. These are the independent variable. X here is the dependent. This is the independent variable. Y here is the dependent variable. So we're looking at y, the y. They are the dependent variable, right? So because it has this coefficient here, this is a constant, it's a number. It could be 2, 3, 4, 5, whatever, but it's a constant. That's why this type of equations are called constant coefficient differential equation. And we want to apply this technique to be able to get an answer. So we are saying that we are concentrating on the differential part of the equation. The y dx is the same as this. So when you reach here, we now want to expand this y here. We are going to differentiate e raised to the x times y. So this is the product. And you know the product rule, differentiation. As I mentioned earlier, this topic, you really need to understand real analysis and linear algebra, this differential equation. If you don't have strong understanding of real analysis, integration and differentiation, you will never be able to understand differential equations. So first, you should go back and watch videos about real analysis and linear algebra before you come to differential equations. So what we are going to do here, we are going to apply the product rule of differentiation to solve this one here. So u dv, you know that formula, u dv, we have u here as e raised to the ax, dv, v is our y, so this is going to be the y dx, plus now v, which is y du. And if you differentiate the u, this is, you will get a e raised to the ax. Product rule of differentiation. Yeah, you have e raised to the ax times y. You want to differentiate it using the product rule. So this is, if this is your u and this is y, your v, so we have Please help me with this one. This one, you want to come with the camera.
Only what you want.
Give you ice cream. Give you ice cream. Yeah. Okay, please take it.
And what happens? You want to race?
You will then have UDV. When I finish, I think go and dress up. Let's go to the shop. Go and dress up.
Well, actually, teaching you.
Yeah, I have to. Go and dress up.
Can I go?
Yeah, go and dress up.
No.
No.
Yeah, I'll go.
Trousers. Go and take trousers.
Let's go change.
Right? So you do this product rule, you get this. And what is this then? E raised to the x, the y, the x, y, a, e raised to the ax. So you can see that this rule, this function here is the same as what is the function, the same as the function on the left hand side of equation 1. So that means this one here, if you differentiate this one here, you get this. That is to say, dx e raised to the axy is the same as e raised to the ax times h of x. I hope you understand that. Because when we split this one here, this was just something to enable us to see what we are doing. This is what we get. And this is what is here on the left hand side. So it means this one alone on the left hand side, we can compress it, then we'll get this one here. So what do we do next? Let me take off this one so that we can have space. We now have y, the e raised to the ax, the x equals e raised to the ax h of x, just copying what I have here. So we have this function here. What can we do? We can integrate both sides of the equation. We can integrate both sides of the equation. You will now, if I integrate this one here, we'll also integrate this one here. We can add this dx will now come here, right? So when you integrate this one, because you're integrating here, here you will get y is y e raised to the ax is equals to if you integrate this, you will get a e raised to the ax h of x. We want y. So y is equals to, and I'll bring this one on the other side. This will now be negative because I'll divide this throughout by the equation. So this now will be e raised to the minus ax times a e raised to the ax h of x. That is what we get as our answer. E raised to the minus ax e to the ax h of x. Let me see what I've done here. Should I put this one here? This one should not be there. Made a mistake about that because we're integrating this one here. Right. So this is what you get. This is the answer to this problem here. This problem here, this is the final answer. So whenever you are given a differential equation of this form, you should know your answer should look something like this. Correct? Can we solve one problem so that we can see what we are doing? Why I left this one? Why I left it? Sorry about that. This integral sign should be there. So this is your answer. Now let's look for a problem to solve for half time. You are given find the solution. Find the solution, solve. 1. Divide the x plus y. Divide the x plus y is equal to, divide the x plus y, right, is the question, e raised to the 2x. They're asked to solve this. See that? They conform. Divide the x plus ay, h of x, you have e raised to the x. So if that is the case, now our y will be equal to e raised to the minus ax. E raised to the minus. But what is a? A here, in this case, a here is 1. A is 1 because there is no coefficient here other than 1. Coefficient of y other than 1. If it was 2, they are going to write 2, but they don't write anything, so it's 1. So your a is 1 and x. We are looking at this formula here. Then you have something like this. Then you have your integral sign. You have again e raised to the a is still 1, and x. Then times h of x. What is h of x? H of x is e raised to the 2x dx. This is your answer. But you got to simplify this one. Can you see?
Wow.
You got to simplify this one. This one is equals to e raised to the minus x, bracket closes,
No.
e raised to the x times e raised to the 2x. This will give us e raised to the 3x dx. Lots of indices. You know this from the lots of indices. So now let's integrate this integral sign. We now need to integrate this. If we integrate 3 e raised to the power of x, 3x, this one you will get, first you have this one here. When you integrate this, you will get 1/3 e raised to the 3x plus c, where c is a constant because this is an indefinite integral. So c is a constant. So let me look for more space. So if we break down this one, or we expand, we distribute e raised to the x, y will be equal to 1/3 e raised to the minus x times e raised to the 3x. Here you are adding, so it will be e raised to the 2x plus this times this, c, that's constant, e raised to the minus x. So this is your final solution. As I told you earlier on, whenever you solve a differential equation, you always get a function. You don't get answer like numbers. like absolute numbers, you get 3, 10, you will always get a solution. Because now on this problem, this C is a constant. Depending on the value of this C, it will give you more or less the vector of this equation, in vector form. If you have different lines, when you change this number with this line, if you increase it by 1, increment of 1, if the line was like this, you add 1, it now go one step above the other, one step above the other. This is what happens, and from there you get a picture of how graph looks like. Thank you for watching. Bye bye for now.